So this unit that we are looking at, Unit 5, is electrochemistry, okay? And electrochemistry, it's called electrochemistry because it has to do with the movement of electrons during a chemical reaction. So the movement of electrons in a chemical reaction. Okay, and you're familiar with, how ions work, right? Ag plus, it lost an electron. If we have O2 minus, compared to its neutral atom, it gained an electron, or actually not one electron, it gained two electrons. And so what we're going to be looking at here is we are going to be looking at not every substance has a charge like this. We're going to be looking at a thing called oxidation numbers, which are like charges on ions, but we can use them for all atoms in all kinds of substances, even in covalent substances. We can use them for any atom in any substance, even if it's not an ion. Okay, and this is a skill that we're going to do sort of in isolation just for today because I don't want today to take too long. So we're just going to learn this, and then there's going to be a Tyler DeWitt video that you're going to watch that will give you a background, like a sort of more big picture on the whole thing, okay? Because it's got some lovely pictures in it that I certainly couldn't draw. All right. So how do you find the oxidation number? Well, some things have oxidation numbers that are, what's the word I should use here? They are really, really easy to remember, and they're really obvious, okay? So rules for finding oxidation numbers. And the first rule is if you have an element on its own, not in a compound. Actually, I suppose I could ask you guys this because you should, in theory, know. What is the charge? What is its charge? So for example, if you have O2, which is an element on its own, if you have Fe, if you have helium, what is the charge of those things? Zero. Yeah, absolutely, right? There's nothing up here. And the charge is zero. And whenever you know the charge of something, you know its oxidation number because its oxidation number is the charge. Okay? The oxidation number is the charge. So oxidation number, I'm going to start abbreviating as ON because it's long. oxidation number. So any element on its own has an oxidation number of 0. So an element on its own has an oxidation number of 0. So rule number 1 is sort of its own little thing, and then we go to atoms in compounds. Okay, so now we're working on atoms in compounds. So if I have an alkali metal, and if you recall, those are Na, let's see, no, let's start with lithium. Lithium, sodium, potassium, rubidium, cesium, francium. If those are in compounds, what is their charge? Yeah, it's +1. They're column number 1, so they have 1 electron in their valence shell. So when they form a compound, they give that electron away to their respective partner there. And so they are all going to be +1. Okay, so therefore the oxidation number of alkali metals in compounds is +1. Now, a lot of people will just leave off the plus, but because an oxidation number is like a charge, you must include the plus. You can't just leave it blank. Okay, because oxidation number is like a charge. You must include the plus. So it wouldn't just be not just 1. Okay, has to be +1. Okay, following along the same trends. Oh, hang on 1 second here. What am I doing? There we go. What is, do you think, the oxidation number of the alkaline earth metals in compounds? Yeah, +2. So their oxidation number is +2. So you already know a whole bunch of these, right? And if I was to say, what's the oxidation number of aluminum in a compound, you'd be like, oh, it's +3. Um, but we're going to just explore a couple of things that have exceptions to the rule, and they're a little bit odd. I just want to grab my document here because I should give them to you in a particular order. Oxidation numbers, there we go. Okay. So for our third one, we are going to have fluorine. And fluorine has an oxidation number of what? Fluorine. -1 in a compound, yes. Okay. These, oh, that should be rule number 4. Um, these first 4 rules are always true. There are no exceptions to them, okay? When we start getting into the next ones, we get rules that are true most of the time, okay? So I'm just going to kind of draw a line between the ones that are always true and the ones below here are usually true. There are exceptions though. Okay, so number 5, hydrogen. What would you imagine the most normal oxidation number of hydrogen is? Oxidation number is usually, it is usually +1. Okay, that's just like in all of our acids, right? H plus. Okay, so hydrogen is usually +1. However, there are some, yeah, it can also be -1. And it will sometimes be -1. So our exception, if you put hydrogen with a metal, it will take on that -1 charge. In other words, it'll have a oxidation number equal to -1. And we call compounds that have hydrogen like that, we call them hydrides because the name of the H- ion is hydride, the hydride ion, because of course when we have a negative ion, its ending becomes "ide." So for example, we might have sodium hydride, NaH, or calcium hydride, CaH2. Okay, but almost always you're going to see hydrogen with a +1 charge. So if you've got it in some sort of organic compound, CH3COOH, your H is going to be +1. Okay, so unless it's with a metal, hydrogen is always going to be +1. So that is our exception. Our exception is when it is with a metal, and it's with a metal, the oxidation number is -1. I have on the worksheet I have for you, these are all listed out like really in a tidy fashion. Okay, number 6. Again, this falls in the usually true category. Oxygen. What is the charge of oxygen usually? The oxidation number is normally for oxygen, charge of oxygen, -2. Yes, indeed. Okay, so -2, O2 minus. But you will see some weird compounds every once in a while. Okay, exceptions. Well, it's just one exception, really. It just happens in different places. What if I had H2O2? Hmm, it's a strange one, isn't it? Or what if I had Na2O2? Yeah, don't worry. If you have to leave early, that's totally fine. The rest of this will be recorded and you can just check it out later. Okay, a couple people have a quiz. So yeah, no big deal. Okay, so if you have Na2O2, well, these rules are written in order of priority, okay? So if I look, I'm like, oh, alkali metals, that's like one of the high up rules. So that's going to take precedence over oxygen because sodium is never anything other than +1. So what we have is we have sodium, which is +1, and we have sodium, which is +1. That means that the charge of each oxygen must be -1. Yeah? And in fact, there is an ion that is called peroxide, okay? And it is O2 2 minus, okay? And so when you have a metal and it's not combining in the normal way with oxygen, normally you would have Na2O, which is two Na pluses for one O2 minus. But if you see something weird and you're like, oh my gosh, that is not a formula that should happen, then you can say, oh, okay, maybe I have a peroxide. Okay, so you've got your sodium and you've got that, and there you go. Um, let me just think. I just want to give you guys an example of something where people sometimes think they're a peroxide and it's not a peroxide. Okay, not a peroxide. H C2H. Let's see, CH3 3O2. There's a compound. It ends in O2. Sometimes people see this O2 and they think peroxide. But if it's in an organic compound, there's nothing else there that has a rule that is more important than oxygen. Yeah, there's hydrogen, but carbon's going to fall down below oxygen in the order of the rules. So you can say, no, no, it's not like paired up with a metal. It's not paired up with hydrogen, which is also higher on the scale of importance, right? If you have hydrogen peroxide, you have an H plus and an H plus, and you'll have an O minus and an O minus, which means that in peroxides, the oxidation number of oxygen is -1. Okay, so in peroxides, the oxidation number of O is -1. But that is not the case here. This is not a peroxide. The oxidation number of O here is -2, just like normal. Okay, you should really not be seeing very many peroxides. Peroxides are rare. Okay, people hear about them and they start looking for them everywhere. Don't look for them everywhere. Just assume that oxygen is -2 unless it's absolutely not working out without it. Okay, so if you come to something like, I don't know, CaO2, you might be like, oh, hang on, calcium's 2 plus. If oxygen is 2 minus, then that formula doesn't work. So that must mean that I have a peroxide. So I don't have O2 minus, I have 2 O minuses. Yeah? Anyway, don't look for peroxides. They're really rare. I only mention them because they do show up every once in a really long while. All right, what number was that? That was number 6. Number 7 is the halogens. Okay, and halogens are almost always, the oxidation number is usually, just like fluorine, -1. But there are many exceptions. Okay, like you'll see ICl5 and you'll be like, what? Okay, and so you're not going to worry about that too much. Don't worry about the exceptions for the halogens too much. Just realize that they exist. Okay, let's just do a couple of examples of how to figure out ones that are not part of our rules. So if we have, let us find the oxidation number for chromium in Cr2O7 2 minus. Okay, now all the oxidation numbers of all the chromiums and all the oxygens have to add up to -2. So all the oxidation numbers of all the chromiums and all of the O's must add up to -2. Because if we think of oxidation number like a charge, if we add up all the charges of chromium and all the charges of oxygen, we should end up with the overall charge of the species. So what this means is we can set up an equation that looks like this. We have 2 chromiums and we have 7 oxygens. And when we add those things up, we get an overall charge of -2. Okay, that is our overall charge. And over here, what we're doing is we're simply adding up the number of each element. The second thing we're going to do is we are going to substitute in known oxidation numbers. Okay, so 1, you're going to add up all the number of each element and have it equal the overall charge. Number 2, you're going to substitute known oxidation numbers. So for whom do we know the oxidation number in this question? Do we know it for Cr? Do we know it for O? We know it for O, and O is -2. So in our equation, what we're going to do is we're going to say I still have 2 Crs, but now I'm going to say 7 instead of O, I'm going to write -2. Okay. And then that's overall going to equal -2. And now at this point, we just do the math. Okay. So step 3, do the math. And you're going to solve for Cr because we are looking for the oxidation number of chromium in this case. So I'm going to do like all the math. I'm going to probably do more steps than you normally would. -14 equals -2. And then we have 2 chromium is equal to -2 plus 14. And so now we have 2 chromium is equal to +12. And now we're going to have chromium is equal to 12 divided by 2, which is 6. But don't forget that an oxidation number must always have a charge. Okay, so let's try another one here. I'm going to give you a weird one. This is going to be fun. Okay, we want to find the oxidation number for carbon in C3H2O2. Okay, is this a peroxide? I got that O2. Is it a peroxide? No, okay? It is organic. It's an organic, yeah. So you'll see O2s in organics all over the place. Don't let them throw you, okay? If you have carbon-based compounds, those are going to be organics. And you'll see O2s in there all the time, and they are not peroxides. Peroxide, unless it's with hydrogen, it's going to be with a metal. Peroxide will always be with a metal or hydrogen. It'll be with something with a positive charge, okay? Okay, so let's try this. We are going to add up all our elements, add up the number of all the elements. So that's going to be, there are 3 carbons plus 2 hydrogens plus 2 oxygens equals, and then it's going to equal, remember, the overall charge of the species, which in this case, our overall charge is 0 because we ain't got nothing, right? There's no little charge up here, right? So our overall charge is 0. Second thing we're going to do is we are going to sub in known oxidation numbers. Okay, so we don't know carbon. Carbon's actually what we're looking for, right? So that's our unknown. That will be our variable in our question. So we're still going to have 3 carbon plus, we know hydrogen is normally +1. Feel free to refer to your rules until you have them memorized. Oxygen is -2, and overall that equals 0. And then 3, we're going to do the math. Do the math, solve for carbon. Okay, so 3 carbon plus 2 minus 4 equals 0. 3 carbon minus 2 equals 0. 3 carbon equals +2. So carbon, whoa, this is weird, hey? It's equal to +2/3. Yes, your oxidation number can be fractional. Yes, oxidation number can be a fraction. Okay, so if any of you need to leave at this point, if you haven't already left, you can feel free to leave because I've shown you the worst of it. That's about all there is. I've got one more example that I'll show everyone else just to be sure. Okay, so one last example here. What if we had, um, find the oxidation number of lead in, no, oops, I have to change up that worksheet because I've got an error, of uranium in UPO4 2. Okay, now this is one thing that is a little bit tricky because you look at this and you're like, hang on, what's the oxidation number of P? I don't know that. I'm going to have a problem. There's one extra little tiny thing that you need to know is that if you're trying to find the charge of a metal, if you're trying to find the oxidation number of a metal, and it is combined with a polyatomic ion, okay, if you're trying to find the oxidation number of a metal and it's combined with a polyatomic ion, guess what? You know how to do this. You've been doing this since grade 9. What's the charge of uranium in UPO4 2 minus. Or sorry, if you've got uranium with 2 phosphates, yeah, it's going to be +6 because PO4 is -3 and you have 2 of them, right? And so uranium must be +6 so that you end up with an overall neutral compound. Okay, so don't get tricked by that. That's the only sort of thing that doesn't just follow the straightforward rules, is if you're like, I don't know, it'll probably just be that you have a metal with a polyatomic ion. Are there any questions? Okay, this week's assignment is going to be, if you haven't finished the quiz, finish the quiz. Number 2, you are going to do the oxidation number worksheet. And you're going to do, there's a whole ton of questions on there. We're going to spread them out so that you like get practice over time, which is the best way of remembering things. So you're going to do just numbers 1 through 13. Okay. And then the third thing you're going to do is there is a Tyler DeWitt movie, video. Tyler DeWitt, I think it's about 17 minutes long. It's an intro to electrochem. So it'll give you sort of the overall background of why we're doing this. What is this all about? Why are we bothering finding the oxidation numbers of things? To electrochem. There's 2 ways you can do this. You can either take your own notes, or I have fill in the blank notes. But I know that, you don't might not want to like print out fill in the blank notes. So you can just take your own notes if you prefer. Or fill in the blank notes. Some of you have computers where you can draw things and whatnot. So you could just write on the notes in your computer. So whatever works best for you, just make sure you're kind of getting the general gist of what's going on there. We will go over all of that material next day, Tuesday, Friday at 9:30 a.m. How about I just set that? And if it turns out to be, if it's a problem, send me an email and I'll try to arrange a different time. Okay? Have a great week. Enjoy that sunshine. Gorgeous out there. Get outside today. Bye.